Assalamualaikum and hi everyone. We are from group 2 and we will be presenting on endosulfan on water surface near tea plantation areas.
Starting off with the case overview of endosulfan. So, what is endosulfan? Endosulfan is a man-made insecticide. It is a chemical that promises to protect crops and control pests such as aphids, fruitworms, beetles, leafhoppers, moth larvae, and whiteflies on various crops. It appears as a brown or colorless crystalline solid with a pungent odor that's said to be similar as turpentine. So, endosulfan was initially created in the 1950s by Faubourg Oaks. It started as one of the best solutions for pest problems then. Around the 1970s, concerns about the usage of endosulfan started to arise. Concerns regarding the extreme toxicity of endosulfan to people and animals started to surface with many aspects, including a threat to human health and environmental impacts. Moving on, what are the impacts of endosulfan? Firstly, its danger to wildlife. Contaminated food sources and habitats can harm wildlife as the animals will ingest food such as plants. In the end, this can affect their health and lead to declination of the species population. Secondly, environmental impacts. Dissolved endosulfan in the water can impose a huge warning on the environment such as soil and water contamination. Hence, aquatic lives and soil health will be affected. It also causes bioaccumulation in the environment. Lastly, threats to human health. Long-term exposure to endosulfan has been shown that it affects the genetic factors of human. It can also disrupt human endocrine system and affect the hormones. It has also been shown that it can cause birth defects. Starting off with the sampling method of endosulfan near the tea plantation area. Firstly, the identification of study areas. Study areas are identified with the potential of contamination of endosulfan. It can be conducted through review of secondary data, interviews with rural healthcare providers, farmers, environmental officers, and other agricultural personnel, and field observation. Secondly, field sampling. Grab samples are collected in the chosen sampling sites. Samples are collected in a rotating cycle that has been standardized. And lastly, samples were collected directly in clean, dry, amber glass bottles fitted with a screw cap lined with clean aluminium foil. Samples were kept in an ambient temperature in a holding box for transport to the laboratory where they were stored in a refrigerator until extraction. Thank you.
Moving on to the next part, which is extraction method used for endosulfan on water surface near tea plantation areas. There are three methods that can be used for this study case. There are liquid-liquid extraction, solid phase extraction, and solid phase micro extraction. Liquid-liquid extraction is a method that pulls a compound from solvent A to solvent B, where both solvents are not miscible. On the other hand, solid phase extraction is a method used for isolation and concentration of analytes from a gas, fluid or liquid flowing sample stream by jet transfer to an retention on a solid phase substance. Solid phase microextraction method is a SPE method that involves the use of a fiber coated with an extracting phase that can be a liquid or a solid, which extracts different kinds of analytes from different kinds of media in liquid or gas phase. As we all know, each method has their own advantages and disadvantages. For liquid-liquid extraction method, the advantages are it is a widely known technique which makes it easier to find information. It is good in collecting a lot of analytes, effective for extracting hydrophobic substance, and has a higher recovery rate compared to the other two methods. However, the disadvantages are it is time consuming, requires large volumes of organic solvents which raise concerns, and has a risk of forming emulsions making separation difficult. The next method, solid phase extraction, has advantages such as shorter analysis time compared to LLE method. It has a good selectivity and efficiency, reducing interference from other compounds. It uses less solvent compared to LLE method. produce cleaner extracts with fewer impurities, environmental friendly, and can be automated. Meanwhile, the disadvantages of using this method is that SPE method could cost much more money compared to pilot method. It requires specific instruments to carry out the method, and it requires careful selection of solvent and optimization method for the target analyte.
For solid phase microextraction, the advantages are compared to the three extraction methods. SPME is the fastest one. It also uses very small amount of solvent and can be directly coupled to analytical instruments such as gas chromatography. While being environmentally friendly, SPME is also highly sensitive. On the other hand, the disadvantages of SPME is that it has a high cost and can only handle smaller sample at one time. In addition, the fiber for SPME is fragile and requires very delicate handling. My group chose solid phase extraction as the best method for this case study. Why do we choose this method is because SPE has a high selectivity and sensitivity. It can effectively separate endosulfan from other potentially interfering compounds and can achieve high sensitivity for low concentration of endosulfan. SPE also can manage a large sample volumes compared to SPME that can only handle small sample. SPE also has a wide range of solvent selection, making it versatile. And lastly, since it can be automated, SPE can save time and improve the consistency in processing multiple samples. Next, for the possible solvent to be used, we choose Fluorosil. Fluorosil is highly selective for pesticides and can handle complex metrics such as this case study, which is surface water near a plantation area. Since plantation area might have matrix interferences, such as other organic materials in the water. We also suggest some solvents that can be used. For a conditioning step, we pick hexane as it can activate the Fluorosil. For washing step, we only choose water to remove other possible interferences. And last but not least, for elution step, we pick acetone to dissolve the adsorbed endosulfan.
Move to the next part, which is analytical instrumentation. The first one is a Physense GC800 series gas chromatograph equipped with an ECD system. Gas chromatograph with an ECD systems are highly selective detectors commonly used for detecting environmental samples, as the device selectively detects organic compounds with moieties such as halogens, peroxides, quinones, and nitro groups, and gives little to no response for all other compounds. Therefore, this method is best suited in applications where traces quantities of chemicals such as pesticides are to be detected and other chromatographic methods are unfeasible. One is the fused silica capillary column with 5% diphenyl to 95% dimethylsiloxane liquid phase. Fused silica capillary column have high separation efficiency due to their narrow bore and are resistant to degradation and contamination, ensuring consistent performance over extended periods. The columns provide high resolutions due to their ability to separate closely spaced peaks and detect minor components. They are used to separate volatile compounds and are particularly useful for analyzing mixtures of organic compounds. The third one is the oven temperature. 80 degree ramp at 15 degree per minute to 250 degree, ramp at 5 degree per minute to 300 degree, and held for 10 minutes. The function of the oven is to heat the sample and the stationary phase in the column to facilitate the separation of the sample components. The column temperature is selected to compromise between the length of analysis and the level of separation. A temperature program allows analytes that elute early in the analysis to separate adequately, while shortening the time it takes for late eluting analytes to pass through the column. One is the split and splitless injector in the splitless mode for the SPE extract analysis and in the split mode for the SPME desorption. Split injection is preferred when working with samples with high analyte concentrations, whereas splitless injection is best suited for trace analysis with low amounts of analytes. The split injection is useful when working with complex samples or when trying to reduce the contamination, while the splitless injection is used when high sensitivity and detection limits are required. The last one is the helium with a column head pressure and nitrogen as a carrier and makeup gases. The helium as a carrier gas is used because of the efficiency separation, high column efficiency, while the nitrogen as a makeup gas is used because of the flow control, column protection, and a detector maintenance. Both are used to improve separation efficiency and resolution, increased column life due to reduced pressure drop and reduced risk of contamination, and simplified instrument maintenance and reduced downtime.
In conclusion, endosulfan is a synthetic insect pesticide that developed in the 1950s. It has been effective against agricultural pests, but somehow it poses significant health and environmental risk due to its extreme toxicity. Solid phase extraction (SPE) was identified as suitable method to extract endosulfan due to its selectivity and sensitivity. And the analysis was optimized using gas chromatography with Phison's GC800 series and an electron capture detector (ECD). It is important to phase it out in favor of less toxic alternative while enhancing regulatory monitoring, promote safe handling, and practice disposal. Research and development also should focus on alternative pest control methods and improve detection techniques. Other than that, public awareness and farmer training also crucial to practice sustainable farming along with the policy advocacy to restrict the use of highly toxic pesticides. Implementing these strategies will mitigate the risk of endosulfan, ensuring safer agriculture practices while protecting the environment and health. That's all from us. Thank you.